Have you ever asked yourself what multithreading is? How multithreading works on the Windows platform? Or if a VBA in Microsoft Access is capable of multithreading? This video has a couple of answers for you. Hi, I'm Philip from codekabinett.com, and today I'm going to talk about multithreading. And I think we should get started with what multithreading actually is. Usually all VBA code is executed sequentially. So one procedure will run after the other, and only when one procedure is finished and returns, the next can be started. And while the VBA code is running, the user interface might be blocked, mostly. And that is because Access and VBA, at least the custom VBA code you write and the custom programming language you put into Access is running single-threaded. There is just one thread of code execution. Even if you are able to click multiple times on a button while code is running and these clicks are registered by the operating system, the code of the button click will only execute after the actually running code right now finishes. Only then the next click will be processed or the next keystrokes will be processed. You can hit the keyboard already, you can click with the mouse. The operating system will register these mouse and keyboard events and put them in a queue, but Access will only process the queue once it finished processing all code that was running already while you caused these events. That is single-threaded code. Now, with multi-threaded code, it is possible to execute multiple procedures in parallel. So you could start some code that is running and you would be able to start another procedure or the same procedure once again, and they would run in parallel. And that is becoming more and more important nowadays. Like 10 years ago, it was not that important because our CPUs were becoming faster and faster and faster. And even with code that was executed sequentially, with newer hardware, with newer CPUs, it would be executed faster. But today we kind of hit a limit in CPU speed, and we cannot make the CPU run any faster. But modern CPUs have multiple cores. Like in the past you had the ability to put multiple CPUs in your computer, and nowadays even if you have one CPU unit, one processor, this processor has multiple CPU cores that basically act like multiple processors, and modern computers are much more capable of executing multiple routines in parallel. And that is what currently drives the performance boost in computer technology. I'm not an expert in this topic, so I'll leave it there. But just keep in mind, we cannot make run code faster than it is by upgrading hardware, but we can execute more code in parallel at a time. That is where hardware is getting better and better at the time. So multi-threading is becoming more important. But multi-threading is not all daisies and sunshine, because if you actually write multi-threading code, you increase the complexity of your code by a real huge factor. It becomes much more difficult to debug multi-threading code. And there are much more details you need to take care about. Like the most important thing in that regard is resource contention. You are now executing multiple lines, multiple threads of code in parallel, and they might all access the same resource, and that is a recipe for disaster, unless you really synchronize that. As an example, just imagine you are sitting in a restaurant and your glass is half full and you ask the waiter to refill your glass. So the waiter is one thread, he is approaching your glass and is beginning to refill your glass. That is one thread. And you are another thread. You are thirsty, you want to drink. You grab your glass and drink. Yeah, wait a minute, the waiter is just refilling your glass. So if you pull the glass away, there is going to be a spill. And if such thing happens in a computer program, the program will most likely crash. So you need to synchronize access to a shared resource, your glass. And you need to, in real life, that's pretty easy. You, as an intelligent person, you see the waiter is pouring new liquid into your glass, so you wait, you will not pull it away. But a thread in computer programming is pretty stupid. He does not take notice of such things. If he is instructed to grab the glass, he will grab the glass, and he will not be aware of any other thread doing something else with the glass. So you need to build some sort of synchronization around your glass or any shared resource in your program to prevent multiple threads access the very same resource at the same time. At least not in a way that interferes with the other threads accessing the resource. So this is a reason why multithreading makes things very much harder for programmers. So, is Access able to run multi-threading code? And I was recently involved in a discussion on a forum on that topic, and one person said no, that's not possible because VBA is interpreted code and the VBA interpreter can only run one thread at a time and he will serialize all access to VBA code. That is not true. First, VBA is not really interpreted code. It is compiled to some sort of intermediate code, some bytecode that is not machine readable or machine executable in the first place. It still needs the VBA environment, the VBA runtime, but it is compiled to a form of code that is much easier to run for the VBA runtime. It is not necessary to kind of interpret your source code each time a procedure or any VBA code is run. That is not true. And it is also not true that the VBA environment kind of serializes any code that runs. Not true. And I will show that in a minute. You can run VBA code in parallel in multiple threads. Another point that was made by someone was, well, the whole Office library and Access, they are based on the COM, the Component Object Model technology. And COM is only able to run single-threaded code. Well, that's not true, but it's not entirely false either. And that is where our core problems with multi-threading in VBA and Access are residing. When you create a COM component with C++ or a similar language, then you, as the developer, need to make all your objects and all your code thread safe. It should be able to handle multiple threads. That includes the synchronization of threads accessing the same resource and making all your code able to handle multiple threads. And if you didn't do that, you could leave it there and you could mark your whole library as STA, that is single threaded apartment. It is meant to run only in an apartment, in a sort of container, in a memory area that is only single threaded. And all the components can rely on there will only be one thread at a time accessing them. And it appears that is what the Microsoft Office developer team did when writing the Office object libraries and the VBA libraries and all that stuff. But that is not it does not have to be that way if you are creating a COM component. You can also create COM components and you as a developer make sure they are all capable of multi-threading, and then you can mark this library, this executable or whatever as MTA, multi-threaded apartment. It is able to run in a multi-threading environment. So it's not basically COM which is the bottleneck, but it's the decision of the developer creating the library. So, and I said I'm going to show you some code that is multi-threaded and running in VBA, and I will show you how it is done and how multi-threading basically works on the Windows platform, at least from a VBA and Windows API point of view. And I'm not going to dive into the deep internals there. Okay, let's go. I dug up some really old code for today. Like 20 years ago, I wrote some sort of mail client in Access in VBA. And part of that was encoding files, attachments, to send them via email. You cannot just take a binary file and send that via email, because that would look like this code here, but that is actually a JPEG picture. And if you would send that via email, many of the characters cannot be transmitted correctly and would get lost on the way. So you need to encode them with base64 encoding, and I wrote that. And if you apply that to that binary file, it looks like this. These are only the very first 500 characters of that file, so only a very tiny bit of it. But if you look at this and you previously looked at the source code of an email, you might have seen something similar, and that is just a binary file encoded with base64. And I'm not going to dig any deeper into that base64 encoding here, because the code I wrote back then is horrible. It is very inefficient and slow, and I would not want to use that ever again. The only benefit it has for our example today is that it is using only very simple string functions to kind of encode it with base64. And that is actually something that we can use today, especially as this code is, as I said, very, very slow and would benefit a lot from being processed with multi-threading. So let's look at the actual code here. We just read that unencoded stuff into a buffer, and then, and this is actually a thing you need to think about when thinking about multi-threading, we determine the length of that buffer and our thread count, and then we determine the individual pieces. So we need to split up that whole file in that buffer and split it up to distribute the work to multiple different threads. So the next bit here, that is just let's look at that. That is nothing of importance. It's just a loop here to max out the CPU. And you will see in a second for what that is important. Back to our actual multi-threading stuff. And now the important stuff. This is now the thing where the threads get started. So this block is actually creating threads, and the really important part is the create thread method here. Now we loop through that for loop here for each thread we want to create, and then call the API function create thread. That is just an API declaration. I'm not showing the declaration because I think it's not that important, at least not from the level we are looking at it. And one part that we need to look at is this. We pass in a ThreadProc, and that is the actual procedure that is doing the work. And the ThreadProc, I'm going to show it in a minute, we cannot pass that directly, but we need to pass the address of the ThreadProc. That is basically the address in memory where that procedure resides. And we pass in the thread index here. Well, that's the thread index to give an information to the thread which index, which part of the buffer he is supposed to process. And that is actually a thing that is prepared here. We split our long binary string into several parts and put it into an array of strings. And each item in the array is part of the string. And so we can pass parts of the string to different threads. Now, after we call the create thread here, the threads are working. This is where the actual work happens. But in this thread, this is our main thread, that is not implemented here because that is in the ThreadProc. So maybe we jump to the ThreadProc in between. That is very simple. I just added this call initialize stuff here. This is supposed to tell the environment this is a thread that wants to be multi-threaded. I'm not sure if that actually has an effect. I thought I added here to kind of make it clear for the runtime that this thread wants to be multi-threaded, but I'm not really sure if it has an effect. But I left it in here because it does no harm. So the really actual work bit of this thread is this block. We read from our input buffer. That's where we're shoved in a parts of the string to be encoded. And we read with using the thread index variable, you read that part that this thread is supposed to process into a local buffer, and then this is where the actual work happens. We encode this part of the raw binary string. We encode it with base 64 and write it to this output buffer. Back to the multi-threading example. Oh, and I just noticed I forgot an important part in the ThreadProc. Let's jump back to there. We need to make the output accessible, and that line was missing here. So we just keep that output buffer array that is working similar to the input buffer. That is the output buffer where the ThreadProc writes it results. And now we look at the ThreadProc once again, and here we dimension our input and output buffers, and these are just in the declaration area. These are two very simple string arrays, and they are in the declaration section of the module, so they are accessible by all the methods inside this module. So back to the multi-threading example proc. We looked at this part here where we create the threads. We looked at the worker proc that is doing its work here where there is no code. And now we look at how we join all the threads back together again. And that is this block here. We wait for the threads to complete. And this is another API function that is used for that purpose. This is running in our main thread, the usual VBA thread. And then we call this wait for single object function. And that will make this thread stop and wait until the worker thread completes. And that is quite important. If you don't do that, Access will most likely crash here. So we cannot really do background processing while the user is working. That is not going to work. But we can spin up multiple worker threads and parallelize the work while the actual normal VBA thread is sitting here and waiting for the workers to complete the work. And that is what wait for single object is doing. And we use that in that for loop here. And we loop through each thread for from 0 to thread count and loop through that and wait until each thread completes. There is a better option. There's a wait for multiple objects that would be better suited for that purpose, but I was just too lazy to implement it because it does work this way as well. And for this simple example, I just was too lazy to do the effort. And finally, we have this part here where we access the output buffer. That is where each thread puts his part of the result, and then we join that back to a huge total buffer with the encoded file. Okay, so this is it so far. Let's look at CPU utilization. I hit the run button. Now we see this is the max out function that you probably remember. And this is running on one core. And this is finished now. And you see that now probably this CPU here, that is the real working CPU where the worker thread is running. So you see already we have only one worker thread yet. Oh, I forgot to show that. I'll come back to that when the execution finishes. I configured the code to use only one worker thread, and that is on this CPU here. And that is doing the work. Okay, let's take a quick break here. I want to make sure that you are aware if you actually want to try something like that. I want to make sure you are aware of a couple of pitfalls you should avoid. And these are quite limiting in the use of multi-threading in VBA. You must never touch any object. I guess that's because the STA thing, the single threadedness of the Office libraries. You must not touch any object at all. Not even your own classes. If you do, it's pretty sure your code will crash pretty soon. Another thing that is absolutely crucial, you always have to make sure your code is completely compiled. Usually VBA will compile code on demand. You can just type in new code and click run, and then VBA will compile the code that needs to be run right now on the fly and then execute it. If you do that with multi-threading code, Access will crash. Another thing you should avoid is any do events. Do not use the do event statement neither in your multi-threaded code, in your worker thread code, and not in the main thread while other threads are running. If you do that, it sometimes works, but it's pretty sure you are going to make Access crash. And one more thing, you should never call any method that has any effect on the user interface. And that is basically included in never touch any object, but it is really important in one regard, mention it specifically. Debug print will print something into your immediate window. And the immediate window is a user face element on the screen, and that might make Access crash if that is executed by a background thread, by a thread you created and not the main Access thread. So during that short interlude, this thread actually finished, and you see the output here. That is the main thread down here. You see the next line is outputting the thread ID and handle of the new thread. And then that thread is running and working, and now down here we are waiting for the threads to finish. That is that part here, the two debugs here and here. And finally we have this code down here that just outputs the number of seconds elapsed, and that are 161 seconds it took to process the file with just one thread. And now let's look at real multi-threading. You saw already when we looked at the CPU utilization that we had different threads. One that was the main Access thread and another one processing the file actually. And there was one thread only. Now we increase that to 2 threads, and I once again press run, and let's look at the CPU utilization now. This is once again the max out to highlight the first CPU, and now you see we got one CPU maxed out here. That is one of the worker threads, and then there is another worker thread on CPU 4 here, and you see they are both nearly maxed out. We are finished already. Now it took only 34 seconds. That is because my base64 encoding is not really increasing the time linearly. If you need like 10 seconds for a small file, you would need like 30 seconds for a file twice that big, or maybe even a minute or so, because the duration is exponentially longer. So by splitting up, we did not halve the time, but a fifth of the time only with 2 threads working here. And we can kick that up quite a bit actually. I've got 12 cores in the computer, and you should not raise the thread count beyond the number of cores, because then execution times will actually go down again, because you have threads that kind of fight for the attention or for the processing time of the CPUs. But as I've got 12 CPUs and I'm not doing much else now, so I think 10 threads should be fine. And now we run it, and I quickly switch over here. You see once again on CPU 1, this one is maxed out. And now you should see spikes on almost all the other CPUs. And you see these are only very, very short spikes, because only 2 seconds elapse to process the whole file. Because now each thread had only to process a very, very tiny bit of the file, which is done very, very quickly. And we can use a bigger file here to make that a little bit more visible, but that should still run pretty fast here. And one thing, if we hit the access window, it is kind of frozen here, because our main thread that is updating the user interface is blocked because it does nothing else than waiting for the other threads to complete. And now you see there are much bigger spikes here and much broader spikes, but still the file is 3 or 4 times that size, and still only 11 seconds were needed to process the whole file. If my really poorly written base64 encoding routine had to process that bigger file on just one thread, it would have probably taken like 5 to 6 minutes or so. This is really an impressive result, I think. But always keep in mind that was code that extremely benefited from the multi-threading stuff. And I have to say, I wrote this code in Access 2010. And here it actually works. It proves that VBA is capable of multi-threading. But unfortunately, I tried to transfer the very same code to Access 2016, and I was not really able to make it run without crashing there. So unfortunately, it only works in Access 2010 and not anymore in 2016. But even here, this code works reliable, but it took me quite a while with fiddling, and I guess Access crashed like 30 to 40 times while I wrote this code and figured out what to absolutely avoid when using multi-threading and how to make it work, so it's not really practical in a real-world example. So, should we use multi-threading code in VBA? In a real-world project, in something you ship to your customer, or something that is used in your business by real users? And the clear answer, no, don't do that. Unfortunately, it's really sad, because that was an impressive example what multi-threading can do. But unfortunately, we cannot really use it in a safe way in Access and VBA. If you really have a requirement to use multi-threading, you need to do it in a different way. You cannot implement it in VBA. What I would do if I really had a need for it, I would create a COM component, probably with Microsoft.NET Framework, and then create my multi-threading code in that component, and then use that component as an ActiveX object inside Access and VBA, and only run a single thread in VBA and call out to that COM component, that .NET component for all multi-threading activity I need to have done. That is, on one hand, it's pretty sad. But on the other hand, I had quite a hard time finding that example I showed you that benefited in such an extreme way from multi-threading. The usual Office Access applications, the database applications, where there is most of the code is like user UI kind of adaptation, UI design, and that user interface is kind of controlled by VBA code. And the other thing is you go to the database and fetch stuff, and there's only very little in between. These type of applications usually do not benefit that much from multi-threading code. And if you are on SQL Server, then you would have the ability to use the ADO library to query SQL Server and do that in an asynchronous way. That is the main area where our database applications benefit from multi-threading. And you can do that because then you already have that situation. You have an external component, the ADO libraries, and these implement multi-threading for fetching your data from SQL Server or another active server database. So it is not that bad that we don't have multi-threading code. And always keep in mind, it's extremely hard to debug this type of code and the unexpected errors that come with it. So don't be too sad that we don't have it. But I think you gathered a bit of understanding what multi-threading is, how it works, and how it can be implemented in another language. So I hope you learned still something useful today, even though you cannot use it in VBA. But at least you know why it does not work. Okay, thank you very much for watching. Like the video if you enjoyed it, and subscribe to my channel if you like more videos of this type. Thank you, bye bye.